Question number 11 says, on a square handkerchief, 9 circular designs, each of the radius 7 cm are made. Find the area of the remaining portion of the handkerchief. So over here we have a square shaped area where 9 such circles are made. Refer to the book for the exact diagram. Let this be A, B, C and D. So the radius of one circular design is 7 centimeter, right? How will we find out the area of the remaining portion of the handkerchief? We will calculate the area of the square, then we will calculate the area of the 9 circles and we will subtract. We know radius of one circular design, therefore we will be able to find out the area of one circle. So the area of one circle is pi r square. This will be 22 by 7 into 7 into 7. 7 gets cancelled. We have 154 centimeter square. So if area of one circle is 154 centimeter square, this implies area of 9 circles will be 9 into 154, that is 1386 centimeter square. Now, how to find out the area of the square? Because the length of the sides are not given as such. But we do know that the diameter of the circular region is, if we are supposed to find out the diameter, we will write over here, diameter of the circular design is 7 into 2, that is 14 centimeter. Therefore, side of the square will be how much? If you must see in the diagram, children, there are three circles, isn't it? 1, 2 and 3. So if I take all the diameters of the first one and of the second one, then of the third circle, what will I get? I will get this diameter. Now these are joined, okay? Children, in my diagram it is not joined, but if you see the book, it's joined. Then again 14 centimeter, again we get 14 centimeter. So 3 times 14. So side of the square will be thrice of diameter of one circle. Thrice of diameter of one circle. So we get the answer here as 3 into 14, that is 42 centimeter. Now we know the side of the square, we will be able to find out the area. Therefore, area of square ABCD is equals to side into side, that is 42 square. And the answer is 1764 centimeter square. Therefore, area of the remaining portion of handkerchief, area of the remaining portion, of the handkerchief will be area of square ABCD minus area of 9 circular designs. So over here we get the answer 1764 minus 1386. We are left with 378 centimeter square. This completes your question number 11. After this, we will move on to question number 14. And question 13 and question number 12 are your homework. Okay, this was the question number 11. So question number 12 and question number 13 are your homework. We will move on to question number 14. Question number 14 is, AB and CD are respectively arcs of two concentric circles of radii 21 centimeter and 7 centimeter at center O. If angle AOB is 30 degree, find the area of the shaded region. So over here you can see, children, there is a sector, the bigger one, AOB, of 21 centimeter. So what is given in the question? Angle AOB is 30 degree. Radius of the bigger sector is 21 centimeter, and COD, this particular small sector COD, the radius is given as 7 centimeter. And ABCD, this particular region is the shaded part. Alright. So how to solve this? We will take the area of the bigger sector minus the area of the smaller sector. So let us move with the solution. Here, after writing what is given, you will write area of the sector AOB. Area of the sector AOB is theta upon 360 degree into pi r square. So theta is 30 upon 360 into pi is given as 22 by 7 into 21 into 21. So we are left with 1 upon 12. This goes 7 ones are 7 threes are, 2 six are, 2 11s are. So over here we are left with 11 into 3, 33 multiplied by 21 upon 6. On solving, we will get the answer over here as 200. After simplification, we will be left with 33 multiplied by 21, 115.5 centimeter square. Sorry for the loss of connection, children. Then area of the sector COD, we have 30 upon 360 into pi r square. So over here we get 30 degree upon 360 into 22 by 7 into 7 into 7. 7 gets cancelled. We are left with 1 upon 12. 2 6 are, 2 11s are. So now we get over here 77 upon 6. So on dividing 77 upon 6, we will get the answer as 12.83. Now subtract both the two of the sectors. Area of the shaded part, area of the shaded region is equals to area of sector AOB minus area of sector COD. So over here you will get the answer as, what was the area of the bigger sector? 115.5. 115.5 minus 12.83 centimeter square. Remember, children, always to put the units in centimeter square or meter square, whatever the unit is given. So on subtracting 115 by 12.83, you will get the answer as 102.67 centimeter square. This completes the question number 14. Next we move on to question number 15. It is said in figure 12.33, ABC is a quadrant of a circle of radius 14 centimeter, and a semicircle is drawn with BC as diameter. Find the area of the shaded region. So this is the sort of triangle that is given. ABC is a quadrant is given, and then you have a quadrant and also a semicircle with here. This is from BC, you have a semicircle also. Alright, and this is the shaded portion. This particular part is the shaded portion. So we have to find the area of the shaded region. So the area of the shaded region we will find out by taking out first of all area of the semicircular region and area of this particular segment. Okay. So the let this be region 1. Okay. So we will take the semicircle, that is this full part, and we are going to subtract this particular segment so that we will get the area of the shaded region. So first of all, let us write what is given in the question. Radius of the quadrant is 14 centimeter. So area of the quadrant will be how much? Area of the quadrant of the circle is theta upon 360 into pi r square. Okay. So as very well you can see, if it is a quadrant, and this means the quadrant is always having 90 degree. So you have 90 upon 360 into 22 by 7 into r square, that is 14 multiplied by 14. So this becomes 1 by 4. This becomes 7 twos are, you have 2 twos are 4, 2 11s are 22, 2 ones are 2, 2 ones are 2. We are left with 11 multiplied by 14. So the answer is 154 centimeter square. Alright. Then after that, to find out the area of shaded region that is marked as 1, first we will take the area of the quadrant and then we are going to subtract it with the area of the triangle. To get this particular segment, we will take the area of the sector, then we are going to subtract with this area of the triangle. So after this area of the quadrant of the circle, we got it as 154 centimeter square. Then area of triangle ABC. Area of triangle ABC, we will write half into AB into AC. So AB will be your height and AC will be your base. We all know that since it is a quadrant and the radius are always equal, therefore the height and the base will have the equal length, that is 14 multiplied by 14. This becomes 98 centimeter square. So by subtracting the two, we will get area of region 1. Area of region 1 is equals to 154 minus 98. The answer is 56 centimeter square. Then the second part, we will find out area of the semicircle on diameter BC. Area of semicircle on diameter BC. That is, what is the area of the semicircle? It is half pi r square. Whatever is the area of the circle, you divide it by 2, you will get the area of the semicircle. Alright. Now radius will be what, children? If you see the diagram, if you see this particular diagram, this will be half of the length of BC, isn't it? So for that we need to use the hypotenuse theorem, Pythagoras theorem, to find out the hypotenuse. So here we will write that is equal to half into pi r square. The radius, instead of radius we will write half of BC square. Okay, half of BC square. So for that, let us find out what is the half of BC square. So for half of BC square, we will write BC square is equals to AB square plus AC square. We know that AB and AC will be equal, both will be 7 because they are the radius of a semicircle. So therefore this will be AC square plus AC square, which will give us twice of AC square. right? So BC squared, which is equals to twice of AC squared. Shift the root here. We get the answer root 2 AC. Alright. So BC is root 2 AC, and AC we know it is 14 centimeter. Root 2 AC. Here we have already written that radius is half of BC. Now BC is root 2 AC, so this will be half of root 2 AC is 14, right? So this goes to 7s. Radius we have over here is 7 root 2 centimeter. So area of semicircle is equal to 1 by 2 into pi, that is 22 by 7, into r square, that is 7 root 2 multiplied by 7 root 2. We get the answer as 154 centimeter square. So now we have all the areas. We will simply take out the area of the shaded region. So area of the shaded region is equals to area of the semicircular region, area of semicircle minus area of region 1 that we have taken out earlier. So this gives the answer 154 centimeters square minus 56 centimeters square. We get 98 centimeter square. This completes your question number 15.